Good job. This is our semester plan. It's supposed to be week number 3. Week number 3 with assignment. So I'm going to give you assignment, but since this Thursday will be holiday, Maulidur Rasul holiday, so I will just give you the assignment and you will do if you want to do on that day, and then yes, you may. It's better not to wait until last minute. You just get the assignment and then submit. Inshallah, I will use Quizzes platform. All right, now go to chapter 2. The last slide. I think I haven't apa ni? I haven't shared you our chapter 3 to Google Classroom. Maybe go to this one first, the Jamboard. Right. We have a question here. The question asks you to find R equivalent, which is at these terminals. This is A, this is B. You're going to reduce the whole circuit on your right side here with what? With R equivalent. It's R equivalent. So what I mean is you're going to do this. This is 5 ohms, and then this is the R equivalent. Looking from this side, and you're going to simplify the whole circuit on your right side into R equivalent. Then this is 40, and you're going to find what is I naught. So over here, yeah, I need some volunteers. Anyone who wants to volunteer, yeah, reduce the circuit on the right side here and try to find which one is in parallel and which one is in series. Then you can redraw that thing. Maybe this is 15, and then yeah, you draw the thing and then try to get that R equivalent. You can unmute yourself and then discuss with your friends, and I will get back to you. For those who just come in, you can yeah, we have QR code on the left side. You can scan that one, and then yeah, sign into your attendance. Okay, now concentrate on this part. This is not finished yet, right? Have we discussed this? Saya pun tak ingat saya dah discuss rasa tak. We haven't discussed anything, right, on this?
Belum.
Belum, right? Okay, good. So, how to do this? Okay, you can unmute yourself, all of you. And then maybe you can discuss which one is in series, which one is in parallel. And then I have something, what if I have like, if I put over here to here, the short circuit. What is that equal to? If this is a short circuit in parallel with 60 ohms, in parallel with 15 ohms here, parallel with this, how do I know this one is a parallel? Remember, a parallel is when you have any element connected end to end. Okay, something like this. So if you have a short circuit connected in parallel like this, what do you think R equivalent equal to? If this is R1, R2, R3, equal to what? Maybe R equivalent 1. R equivalent 1 equal to what? Anyone can guess? Anyone? Do you have problem with your internet?
Thinking, madam, thinking.
Thinking, okay, give you time. Okay, you can, the clue is,
1.
you can apply, okay, someone say 1. You can apply parallel rules. Parallel rules. Why is it parallel? Because they are in parallels. Your friend, okay. Kasi. Okay. Parallel rules. So what does it say? If parallel rules. What is the equation for R total?
R1
Inverse.
inverse plus R2 inverse
R1
plus R3
R2
inverse.
inverse plus R3 inverse.
Okay. Is that all?
Inverse outside.
Inverse. Inverse is actually this one, right? Inverse plus R2 inverse plus R2 inverse. Okay. Is it all? That's
No,
all? Or,
there's another inverse outside.
another inverse, okay. But is that all?
Uh,
What is short circuit here? What is this one equal to? A short circuit is like what?
Zero resistance.
Zero resistance. It's like a true wire, right? A true wire. So true wire should have a R equal to 0. So meaning to say you have another one, which is R0. So I just put as a R0 here. And then you know that this is equal to 0. And because of that, we can remove, this one should be R0 inverse plus this, and everything should be reverse and reverse plus inverse. Okay, and then okay, so if you have R1 into R2 into R3, and then you have 0, right? 0 divided by R1 plus R2. Let's say this is the equation, which is I didn't calculate, okay, but according to the textbook, it is like this. So what is equal to?
0.
Anything multiplied by 0, it should be equal to 0. So the answer is 0, right? So what it tells you? What does it tell you here? Anything in parallel with a short circuit
Equals to 0.
there. So meaning to say, if let's say I have a short circuit on this circuit like this, and you know that a short circuit is when you have a end to end connected, right? So this end all connected to one side, and this end all connected to one side like this. Meaning to say these are equivalent here. If you want to reduce R equivalent 1, REQ1 equal to 0 if you have a short circuit like this. But since we don't have any short circuit like that, so just calculate, right? So this one clear? Can I erase this?
Yes, madam.
Okay. I did record this, right? Let me check. Record. Okay, record. Good. Okay, now let me erase this, or I just copy this. Control D. Okay. Ada lagi baru masuk. Okay, for those who just come in, you need to scan the QR code. Because I don't have time to get one by one and tick one by one. Salah. All right, now this one. Okay, which one is in series?
The first one.
5 ohm and 6 ohm.
5 ohms and 6 ohms. Are you sure?
5 ohm and 15 ohm.
5 ohms and 15 ohms. Series or parallel?
Series.
Series.
Okay, if you say this one and this one in series, what is a series? Series should have a one element connected and side by side, right? Side by side. This. This is series. Do you have any element connected in between? Jana, ada orang baru masuk. So if you have element connected in between, something like this, they are not series. Okay, this is not series. So you need to have only two elements side by side. So this is series. Since there's something else, which is this one, then 5 and 15 they are not in series. Okay, you need to understand this. Okay, so we go back to our question. Which one is in parallel or series? Can figure out?
Twelve ohm and 6 ohm in parallel, madam.
Yes. 6 and 12 are in parallel. So you can reduce this. So 6 and 12, they are in parallel. So any other elements with
Also
in parallel?
80 and 20, madam.
80-20.
Okay, good. All right. 80, 20. They are in parallel. And then which one is in series?
60 and 5.
Okay, if I put it, this one is a A. This is a B. Okay. 60, come again, sister. You say something, right?
A and B are in series, madam.
Okay, yeah, they are in series. Why? Because they are connected at one single line here, right? So I just put one single line here. Okay. They are connected one single line. So if it in series, you can add. Right, good. Right.
Then the
Now,
answer is parallel with 60, madam.
parallel with 60. So which one is in parallel with 60? If I put this one as a C, okay, C. Which one is in parallel with 60?
C, madam.
C.
Only C or do we have?
C and
C and 15.
Yeah, very good. So this is 15. So you have your, kejap. Ni C kan? This is C, sorry. So this is 60. So this is R equivalent. Okay. All right. Now, take out your calculator. I want you to find 6 and 12. How to find this? You use the R inverse plus 12 inverse in your calculator. And then inverse everything. And then plus, this is number 1. This is 15. And then 80 inverse plus 20 inverse, inverse everything. Then in parallel with 60. So what do you get here? Okay, 6 with 12. What is that parallel?
Madam, I have question, madam.
Yeah.
So the 15 doesn't have to inverse, madam. The 15 and the 60.
Oh, inverse. Yeah.
It
Because
need to inverse or not?
actually I put this. I haven't touched anything yet. This is parallel, right?
Okay.
This is parallel. So 6 with 12, I put this way. And this is inverse. This is parallel. So 80 with 20 is actually this. Okay. Then this one. Okay, what is this part? 6 and 12.
4, madam.
Okay, good. What? This one? 80 with 20.
16.
16. Right. Okay, so we have 15 here, 20, and then 60. Okay, you can do the, ya Allah. 15 inverse plus 20 inverse plus 60 inverse and inverse everything. Actually, in your calculation, you do not need to show me something like this. No need. Just this part. Okay, 15 and parallel, because I know this sign is actually for parallel, and you're going to apply this. Okay, this side. So this one just for your calculation. I write down like this because I want you to get familiar with inverse sign. So please use your calculator and then do the inverse. And what do you get here?
7.5.
7.5. Everyone get this, right?
Yes.
Okay, good. Okay, good. Now you have this. R equivalent equal to 7.5. Then how to get I note? Up until now, you have learned basic law, right? Basic law. What is that? 5 basic law.
Ohm's law.
Okay, Ohm's law. Sekejap, ada orang.
KVL.
Oh,
KVL, KCL, Ohm's law.
Voltage divided.
very good. Ohm's law, KVL, KCL, voltage divider, current divider. Okay, good. All right, now, can we apply KVL here? Around the loop. If you apply KVL around the loop, then you will get negative 40. Still remember or already lost? 5 I note plus 7.5 I note. You still remember this? Then you
Yes.
okay, rearrange, you get I note. Siapa baru masuk ni? Okay. Siapa dia boleh masuk? Okay. So 7.5 plus 5, you get something. Okay, this is KVL. But how about using Ohm's law? Ohm's law, you know that V equal to IR. I is I naught and R. So how do you substitute? Which one is which one? You're going to find I naught, right? You rearrange and V over R, voltage is 40 and R is equal to 5 plus 7.5. But how do you know a positive and negative here? A polarity there. How do you know? You know that this R is equal to 5 plus 7.5, right? How do you know? Because you need to plus everything in series. Okay, this is okay. But how do you know the polarity for this? The sign. Any guessing?
The
Any guess?
voltage.
C, the polar, the positive one.
The positive coming from where?
The plus sign plus so positive.
Hmm. The one, what law is that? A passive sign
Passive sign.
convention, right? Passive sign convention says a current enters a passive element. This is a passive element, so it should have a positive sign. A current, which is I note here, enters a passive element, which is this R equivalent, should have a positive. So that's why you have a positive there. Okay, clear, right? Then is these two equal? Yes. Right? Can you calculate that? I don't have the answer, but you guys should have the same answer. Any question?
No, madam.
No. Okay, alhamdulillah. So can we move to chapter 3? Because this is the last slide for our chapter 2. This chapter. By the way, I'm going to give you the recording video. So please do not worry if you miss some point. Then okay, this is the last part. So let's go to our chapter 3, and then I'm going to upload you guys with our chapter 3 slide. I think I didn't put the slide on the Google Classroom yet. All right, now this is chapter 3, method of analysis. In method of analysis, you have what we call it as a node and mesh analysis. A node, as the name called as a nodal, is actually coming from node. And you know that a node is when you have two elements or more, okay, two elements or more connected at a single point here, right? So because this is a node, all right, and you're going to find something using this analysis. A mesh is when you have a closed loop or a closed circuit like this. As long as this is a closed circuit, we call it as a one single loop, right? And this is also called as a mesh, one single closed loop. So in here, we're going to apply what we call it as a current input equal to current output. Or summation of current input should be equal to summation of current output. Okay. Right. For mesh here, and we know that KVL around this, we can actually use the equation for voltages around the loop. Summation of all voltages around the loop can be equal to 0. So total of all voltages around the loop, a closed loop, should be equal to 0. So basically for mesh, we're going to apply this. For nodal analysis, we're going to apply this. And then under both, they have something what we call it as a super. And you just put the name super in front and super nodes. And then this one, super mesh. And it involved with what? For nodal, it involved with voltage supply. For mesh, it involved with current source. Okay. For this part, you have a parallel circuit. This is an equivalent circuit. Only that on your right side here, you're going to reduce into a single circuit, which is R equivalent. Okay. But we are not focus on that. What we focus is actually what we will have. V naught is equal to what? If we have it in parallel, what do you think? V naught is equal to? And also this side, V naught is equal to? Since they are in parallel, then This one equal to what? Any guess? Or should I call names? Name. Yes? Any guess? Voltage equal to?
V naught equal to Vs.
Yes. Good. So very good. So V naught equal to Vs. Why? Because they are in parallel. So even this VR here also equal to Vs. Okay. All right. What effect does the resistor has on the current flowing in the circuit? Okay. These are. And you know that if you have it in parallel, you're going to have a current source which will branch out, I1 and I2. And if you apply KCL, you have a IS equal to I1 plus I2. So what do you think? If we have resistor here, over here, then what does this resistor has on the current flowing in the circuit? If you relate with this, kan? If you relate with Ohm's law, I1 is equal to what? Voltage.
R.
Yeah. What happens if you increase R?
I decrease.
I decrease.
I increase or decrease?
Increase.
Okay. Macam ni lah. If we increase Vs, this one will increase, right? This one will be decrease. So decrease of R will increase of I1. So you will have that. If you confuse, then kan betul ke ni? Kan saya yang salah. Boleh je buat macam ni. Vs is equal to I1 R. If you decrease this, you will decrease this. Oh, ke saya yang salah ni? Dah apa guna ni? Okay. R will increase. Betul ke ni? If R is increased, then Vs will. Oh, I increase, then R is decrease. Betul lah. Allahu Akbar. Dah pening dah. Okay. So if you relate with this one, and if you substitute, then this one will be, since this is increasing, what do you think I2 will be? If this one is increasing, then I2 will be decreasing. Because why? Because IS is branch out into I1 here and I2 here. This plus this, I1 plus I2 must be equal to the same IS, right? So if you increase I1, you will decrease the I2. So far so good, or are you confused? If you look at your textbook, you will have some question that relate with what will happen if R is increased or decreased, or the current is increased or decreased. You're going to relate with this. But so far this one okay, right? Because you're going to apply KCL, Ohm's law, and relate voltages in parallel should be the same for parallel. All right, what about current in series? I not equal to?
IS.
IS. Why? Because IS is in series with R. And circuit. Circuit actually the load. And both are same equivalent circuit. So what effect does the resistor has on the voltage seen by the circuit? And you know that over here you have a a voltage source, not a voltage source, a parallel of this current source, you actually have some voltage drop, which is the Vs. And over here also you have something. And over here also you have something, V maybe RL. Okay, so if you apply the KVL, you will have a Vs equal to VR plus VRL. Agree? Do you agree? Around the loop. Okay. So what effect does the resistor has on the voltage seen by the circuit, this R? And you know that VR is equal to IS R or I naught R. If you increase this, what will happen to the VR? Anyone?
Increase.
Decrease.
Decrease. IS will decrease, right? IS will decrease. So the VRL here on the right side will be increasing because this plus this will be equal to Vs. So yeah, just play around with the equation and then you will get the answer. Okay, good. And both are correct. Okay. For this part, you have a terminology. I think this one you're already familiar. A section node is when you have 3 or more, right? 3 or more branches connected. Branches is an element. So 3 or more branches connected at one point. So this is done. Branches is element. Loop is a mesh. Okay, any closed loop. Yeah, mesh also a loop. That does not enclose any other loops. Meaning to say, a mesh is something that the loop should not depend on other loops. Okay, it should not depend on other loops. The loops is independent. Do you get me? Meaning to say, if you have two loops here, this is one loop, and this is another loop. Okay. This is independent. This is independent loops. But if you draw another one, let's say this one, this is a dependent loop. Okay, this is dependent loops. The yellow color here is the dependence loop. So a mesh is actually the independent, this one and this one. So I shall remove this one and this one, just not to confuse you. Okay, but what about the first one, planar? Planar is when you have a circuit that does not cross any other branches, meaning it is a straightforward. Is this a planar or not? The circuit down here.
No.
Huh? Why not?
Yes.
A planar
No
is a circuit that can be drawn on a plane with no crossing branches.
Oh, yes.
What is a branch? A branch is when you have, let's say I have, this is another branch that cross. Maybe if I put it like this, it cross, right? And maybe this one, like this. Is this a crossing or not? Macam susah je nak tengok. Yeah, this is a crossing. This is a crossing, but actually it is not. Nanti I will give you the example for a non-planar circuit. Tapi this part is a planar circuit. So let me remove this part just not to confuse you. This is a straightforward. You have only two plane circuit, so that does not have any other branches crossing each other. So this is okay, right? If you go to maybe your textbook, do you have textbook with you? You go to chapter 3. Chapter 3, maybe page 119. Okay, look at the left side. Is this a planar or a non-planar?
Non-planar.
A non-planar, right? How do you know?
Because the cross by the brush at crossing
Which one is crossing?
the tree. Oh,
3 ohm.
tree.
The 3 ohm.
3 ohm.
Fine. Oh, I cannot highlight this one. It's actually this part. This one. It cross. If you rearrange this one, it's still cross. What I mean is if let's say I remove this and then I want to rearrange, I just put this part like this. Kejap. Yeah. I put like this, 3 ohms. And there's no longer 3 ohms here. Do you think this is a planar or no?
No.
No, it's not a non-planar, right? Because why? It cross here. This is a 2 ohms. It cross this branch. So it's a non-planar circuit, still non-planar. If you move around other side also, it's still a non-planar circuit. Yes.
So means kalau which is all circuit bukan planar. So mana-mana pun tak ada planar.
For our class, we always have a planar circuit. A planar circuit. This is a planar or not?
Planar.
Yes, because this is a straightforward. There's no crossing branch, right? Okay, what about this part on the left side?
Non-planar. Non-planar.
Non-planar? Are you sure?
Planar. Planar.
Okay, let me draw. This is 4 ohms. Just put it here. And this one no longer, right? It's a
Non-planar.
which one? Non-planar? Is it a crossing or not?
Oh,
This is not crossing end, right? Because this end connect to here and this end connect to here. So you don't have any crossing branch like the example in A. Example in A, yes, you cross at this point. This. Okay. So this one, since there's no crossing branch, then this is 4 ohms. So this is a planar. A straightforward plain circuit. Okay. If you so happen you get the question with a non-planar, then you can complain because in our lecture circuit class, we're going to have a planar, a straightforward circuit like this. But maybe they will rearrange like this. If they rearrange like this, then you should know this is still a planar circuit. So if you have like this, please don't complain. You need to understand that this is not a crossing branch. Okay, we go back to our class. Okay, how many essential nodes we have here? Sekejap, essential nodes ni apa? When you have 3 or more branches connected at a single point. Okay. Essential nodes is when you have 3 or more branches or elements connected at a single point. So which one is with that nodes?
between R3 and R4.
Okay, let me name it. This is A, this is B. And you know that the B here is actually connected all, right? Like this. And then this is C, D, E. E. Oops. And then last one, this is F. Okay. Which one is essential node?
B, D, E, F.
Okay,
BDF.
D,
BDF.
D,
BD,
F.
E,
E,
F.
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 What about C? It's only two, right?
Yeah, only two.
C, no.
What about E?
Only two.
Only
Only two.
only two elements connected at that single point. Okay, good, very good. All right. Well, how many meshes we have here? How many mesh? Remember, mesh is a loop that is not dependent on other loops. Mesh is a loop or independent loops, right? And independent loops. So how many?
6.
1, 2, 3, 4, 5, and 6. Good. Okay, how many branches?
Too many.
Too many?
11.
Yes, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, this is 11. What is EB? Ini tak yalah. This is essential branch with unknown current. Tak yalah. Boring. Essential branches. Essential branches is a branch with more than, I think no need lah, because this one repeating notes is all other notes including the C and A, right? So you have B, D, E, F, and A and C. So no need. This one and this one will not be in your exam, so no need to focus. It's actually the same thing. Right, nodal analysis. Okay, nodal analysis is when, it is easy to use this to solve for currents and voltages if you have to find current and voltages in a circuit. So since I said we have a node, right? A node, then you need to apply current entering equal to current leaving. This is what? This is a KCL. Okay, current enter should be equal to current leaving. In my class, I always do a horizontal element like this. From the current will be flowing from left to right, something like this. That's why I draw like this. Okay, and horizontal like this. For vertical, I'm going to have everything going downward. So you should know that in my class only I will be like this. If you go to other class or other video, maybe from other sections, other instructors, they will use something like this. The current will be leaving the nodes, something like this. Okay, because they want to simplify your life. All current leaving will be the same, right? You need to total up current leaving, which is equal to 0. So you don't need to have that positive or negative. This or this method, they are all same. They are all same. You just need to stick with one, either one. If you like this one, then you go ahead, use my method. If you have this part, also same. Okay, but sometimes, yes, you need to take care of the plus minus. Why I use this one? Because throughout my circuit, regardless of how many, maybe we have this. Let's say I just draw a random circuit. Okay, and then I say that horizontal going this side, right? So I will stick all with this sign. Okay, but for their circuit, since they have going out from the nodes, so they will stick with all going out from the nodes. Maybe like this. At this node and going this way, and you will be confused. But still, you can have the same equation as long you follow what? Passive sign convention. You just stick with one, passive sign convention. And throughout my circuit, the blue color here, the soft blue color here, the sign will not change throughout that equation. So you don't need to worry. Okay. You just worry about what method you're going to apply. If they ask you for nodal analysis, yes, you're going to use nodal. If mesh, then mesh. If superposition, source transformation, then you use that. Okay, so what is nodal analysis? There's some steps. First, you're going to identify essential nodes. That's why this is very important. The terminology we learned so far, you need to know what is essential nodes. What is essential nodes? Anyone?
A point that connects
What?
with 3 branch.
3 or
Three or
more, right? 3 or more branches connected at a single point. So you need to understand at least 3. 3 or more connected at a single point. Okay. First, you choose with the most
Hello.
Hello.
Test 1 2 3 test.
Dengar, Mali dengar.
Dengar. Subhanallah.
Ya, Jami.
Cari aku.
Diam.
Tadi kan?
Boleh.
I came here to hack you.
Yes, kami call.
Disconnect. Lepas tu aku sini lah. Lu. Aku sini lah. Ni dia.
Do you hear me?
Yes, madam.
Yes,
Okay.
madam, I can hear you, madam.
I was okay. Shall we continue or just stop? Continue.
Continue.
It's up to you, madam.
We just
Continue,
finished the nodal steps. Okay. All right. Okay. I think I just simplify for you guys the steps. Okay. First, you're going to identify the essential nodes. Essential nodes with the most branches. Come on. With the most branches. And then when you found that, you should do put a ground zero at that with most branches, with the most branches at this. Okay. Then number 3, name every node. Name. So sometimes you have a node with a voltage source attached to it, and this is a ground. And maybe you name it as a V1, but you know that this voltage source is actually equal to 10. Okay, can you hear, brother and sister? Can you hear me or? Okay.
Yes.
Yes, madam.
Yes.
Okay, so V1 here, how do you know the V1 equal to what? You just follow the rules. The higher in polarity, which is this plus sign, which is equal to V1, minus with the low in polarity, the negative sign, which is 0, minus with 0, equal to the value of the voltage source. This is 10. So you know that that point, this node point, is equal to 10 volt. Okay, so for this type of element which have a voltage source attached to this, you do not need to name as a unknown name. You name as a 10. So here you replace V1 as a 10 at this point. Okay, 10 what? 10 volt. For the rest, if you don't have any voltage source attached to it, and you need to know that the other side of the voltage source should be attached to 0. If you have a voltage source like this, but somehow this part is also unknown, which is maybe Vx, then you can just name it as a V1 here. And here maybe V2. Because this is Vx. You cannot name this as a 5 volt at V1. Okay, because this is Vs. That's why the important thing is to label the ground floor, where you ground floor reference point, where you put your reference point. If you put Vs at here as a reference point, then you know that V1 is equal to 5. You already reduced the thing. What is your aim for nodal analysis? The aim is to find the node value. To find the value of each node. Usually like this, of each node. Okay, this is your aim using nodal analysis. Okay, then after that, you already name the unknown. If you know the value, then you write down the value. If you do not know the value, you just pick V2, Vx, V1, Vy, any name. As long this is a unknown name. Okay. Of course, if you want to apply KCL, what should you do? You need to label your current. Maybe this is a direction, right? Before that, draw current direction. So you have maybe this is I1, this going down, I2. So you just label, draw the direction of your current and then label your current. If you don't label, also okay, no problem. This is just to make sure that you have everything in order. Okay, and then what else? You apply KCL. Yeah, when you apply KCL, then you find value of interest. Maybe the question asks you to find what is V2, what is V1. V1 is equal to 5 because of this and connected to the ground. So you need to find the value of interest. And usually what is that value of interest? The nodes value. Okay, I think that's all for our methods. Okay, can you identify here which one is the essential node with the most branches?
The bottom one.
The bottom, right? Okay, good. Then what should you do? You label the ground floor lagi, the reference point. Okay. Okay. What about this? A, this is B, this is C. What is A? A value. Do you know the value or not? And what is B? What is C? Just by looking. Can you identify what is the value for A? A node?
10, madam.
10,
10.
right? 10. How do you know? Because this is a plus sign. A is a higher in polarity. Minus with the low in polarity, which is the ground. And then equal to the value, 10. So A should be 10. So just remove this, replace with 10 volt. Okay, what about B? Do you know any voltage here? Aim is to find the node voltage at each node. So what is B? Do you know anything about B? The voltage value? Do we have any voltage value here? Brothers and sisters? Just unmute because I need to know that I'm still in the class. Okay. All right. No, right. Okay. If you do not know, what should you do? You just name, right? Name that node. So you can name as a B, still okay, or VB, okay, no problem. All right. What about C?
We know the I.
This is a current, right? A current source. What should you know? You need to know the voltage of this node, right? So, do you know the voltage of this node?
No.
No. Yeah.
No way.
So you can name it. So in my case, I just put VC. So what is your value or your value of interest? What is your interest now? You're going to find VB and VC because they are the unknown nodes. What is your aim? To find each node voltage, right? Node of each voltage. So you're going to find what is B and C, VB and VC. So now, next step. Next step is we already done with these two. And then this. You need to apply KCL, right? But before you apply KCL, you're going to have to draw the current direction. And then maybe you're going to label your current. And then you apply KCL. So you can apply this current direction. horizontal to the right and vertical to down. Okay, just follow that. And then you're going to apply KCL at node 1 or at node VB. If you want to apply I, yes, you can. I1, I2, I3, and I4. Just put any random names. And okay, because of that, I have what? I1. This is your interest, right? The C. So I1 equal to the summation of all current entering the node B here should be equal to the summation of all current leaving the nodes. So I1 equal to I2 plus I3. Very good. Okay, what is I1 if you want to relate with Ohm's law? I1 is equal to what? Okay. Yes. You need to use the passive sign convention. So since your current direction is this way, this is I1, and the value for this ohms, the resistor is 1 kilo ohms, and this node is 10, and this node is VB. And because of this passive sign convention of this passive element, you know that entering is a positive and leaving is a negative. So higher in polarity should be minus with low in polarity. What is that higher polarity? 10, the node 10, right? And then minus with VB, low in polarity. And then this is a voltage. What voltage is this? The voltage drop across this 1 kilo ohms. Okay. This one is just for the voltage drop across 1 kilo ohms. And you know that from Ohm's law, I is equal to voltage divided by resistor, right? This. So the V, you already know, which is the V of 1 kilo ohms. What is the R? R is the voltage drop across 1 kilo ohms. So you know that this is 1 kilo ohm. Apply this into your equation here, and you will have 10 minus VB divided by 1 kilo. Okay, this is number 1, equal to I2. Since I2 is entering 5 kilo ohms here, okay, and this one should be a positive, right? Passive sign convention, and leaving is a negative. So higher in polarity is the VB, okay, minus with low in polarity, which is 0, divided by the voltage across this 5 kilo ohm. Okay. Can you try I3 plus I3? What is I3? Anyone?
VB minus
V minus
VC
Okay.
over 2K.
Okay. Yeah, very good. Over 2K. So this is your first equation. But please simplify until you get cantik sikit lah. This is VC. Okay. So how to simplify this? You can do the multiplication of everything with 10 kilos so that you can cross the kilo there. So if you multiply with 10 kilo, then you get 100 minus 10 VB, right? And then equal to 2 VB and then plus 5 VB. This is your math. This is 5 VC. Is it okay? Do I get anything wrong here? No, tak ada. Check. Okay. Then rearrange, and you will have 100 on one side, and then you have 12 VB plus 5. You have 17 VB minus 5 VC. Okay, so I can put it this one as your number 1, your first equation. Okay, number 2. This is the first part. Second is this one. only focus on your the node with no value. The node with no value, which is the VB and VC. This and this. Why not you focus on this 10? 10, this 10. Why not? What do you think? Because the 10 is a value, right? This node is actually a value. So you don't need to focus on that. And then what about the one down here? The ground, the reference point. What is the value at reference point? What do you think?
0.
Yes, equal to 0. So since this one already known and this one also known, only VB and VC is the unknown. So this is your focus, your focus. All right, then we go to the next step, KCL at node VC. Okay, can you identify which one current is entering and which one current is leaving? Because we're going to build up C there, the current equation for KCL. What is the equation for KCL? Current entering.
Equal to current living.
Equals to current.
Okay, this is enter equal to leaving. Okay, so which one is entering?
I1.
No. Only that at VC.
I3.
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 Yeah, I3. Okay.
2.
And 2 million equals I4.
Yeah, with 2 milli, right? 2 milli here. And then leaving is
I4.
yeah, this one. So this is your equation, but you haven't finished with the Ohm's law. So apply Ohm's law there. You have a 2 milli plus what is I3? Let me
VB minus VC.
VB minus VC divided by
Okay.
okay, yeah, good. Equal to I4. Where is I4?
BC
Mm-hmm.
minus
BC minus 0.
0.
0 divided by 10K.
10K.
Minus 0, yeah, you can just ignore that because it is a minus 0, supposed to have VC. Okay, this one multiplied by 10K to remove this side, then you have a VC, and then you have a 5 VB minus 5 VC. And then you have 2 milli. Milli with kilo, you can cross, and then you have a 20. And you have 10, a plus. So this and this, maybe you do the rearrange, and you have a 6 VC. And with minus VB. Okay. Do you agree?
Yes.
Yes. Okay. So this is equation number 2. Do you have your calculator? If you do have, you can use your quadratic equation. If you're familiar with matrices, you can rearrange this using matrices. 17 minus 5, and then you have negative 5 with 6. This is VB and this is VC. And if you follow that, you have 100 here and you have 20. This is using matrices. If you have your calculator, you can use quadratic or matrices. And do you get the answer here? V1 is actually your VB. And V2 is your VC. Okay, use your calculator. Do you get the same answer, or maybe we need to recheck our calculation? Do you know how to use your calculator?
Yes.
Yeah, right.
Answer, madam.
From your, come again? Brother,
We
okay?
got same answer, madam.
Same answer. Good. Same, Everyone should try. Anyone else who get maybe different answer? Same or different?
Same with them.
Same. Alhamdulillah. Okay, very good. All right. I think with that, maybe can we stop now, or do you want to have another example? We're already at 12:44. This Thursday, yes, you will not have class, but you're going to have your assignment. Even though we will have a holiday, but still you need to do your homework. Okay. Is it okay? If you want to try, you can do the next one here. By the way, your assignment will be an open book assignment. So please, yes, you need to at least do your revision first, so that when you get the question, you can just flip around your textbook or your notes. Okay, with that, do you have any question regarding on our first example here?
No.
No, eh? So far so
No.
good. Okay. All right. So with that, let us finish our class with tasbih kafarah and surat al-as. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. بسم الله الرحمن الرحيم. بسم الله الرحمن الرحيم. والعصر